Hi, so I'm Group 10 and we're going to show you how to use stoichiometry to solve the problem right in front of us. So the first thing we have to do in this instance is to write the balanced chemical equation. And as the problem states, it gives us the chemical formula for rust, which is known as Fe2O3. And it also tells us iron plus oxygen gives us rust. And the unique thing about oxygen and other certain gases is they exist in diatomic forms, which will give us a subscript of O2. Now, balancing this equation, if I simply put 2 as a value for Fe and set 3 to O2, and the other side balance the now oxygen, which is 6 oxygen on this side, with 2 in front of the whole thing. Now it's not balanced yet because this will give me 4 iron, so with that we'll put a 4 as Fe and we'll get our balanced equation. Now that we have our balanced equation, now it is time to this equation, 12.5 grams of rust is produced. Now, looking at that fact, we first have to convert the rust into moles. And how we do that is first we have to find the atomic mass of the entire thing. So, iron, according to the periodic table, has a mass of 55.85. And in rust, we have, at least in this instance, we have 55.85 times 2, and oxygen's mass according to the periodic table is 16. So you have 16 times 3, which 55.85 times 2 will give you 111.7, and 16 times 3 will give you 48. And the rounded number is 16 because oxygen's mass is really close to that number, so we're just going to round it for this purpose. And to find the total mass, you add these two together, which will give you 159.7. And in order to convert this into moles, so remember that we started off with 12.5 grams, right? And this has 159.7 grams. So these units then canceled out, and we'll realize that in this instance we will have around 0.08 moles. So remembering that we have 0.08 moles of rust, then we can, in this situation, we can look at the ratio. As you can see, per 4 moles of iron will give you 2 moles of rust, because it's 4 to 2. And this 4 to 2 ratio will simplify to 2 to 1, right? So in this case, since we have 0.08 moles of rust, and what it is asking us is that how much iron will be oxidized in this process. Well, if this is just double the amount that this makes, we can just simply take this and times 2 will give us 0.16. And that is how many moles of iron will be oxidized in this process. After we have reached this conclusion, we can just simply convert it back to grams by putting 0.16 on the bottom as the denominator and the grams of the substance, which we don't know, as x on top, and set it equal to the molar mass of the substance in grams, which we figured out earlier as 58 point. I'm sorry, excuse me. It will actually equal to 55.85 over 1. Now, solving this proportionate will give us x is equal to 55.85 times 0.16 will give us 8.936. And as you see, these units will cancel. And it will give us, leaving us with just grams. And this will be the answer to the equation.